Hello everyone, it's Mr. Salimata over here, and in today's lesson we'll be looking at second theorem problems. Okay, so let's take a look at our first question over here, and the question reads: in the diagram, Q, R, and S are points on the circle center O. If angle QRS equal to 62 degrees, find angle SQR. Yes, so we have been given an angle over here. Yes, angle QRS, which is 62 degrees, and the question is asking us to find angle SQR, which is this angle over here. Yes, this angle right here. So this is the angle that the question is asking us to find. Yes, okay, so now let's try to look at our question over here. Yes, let's look at this straight line. Yes, QR, that is passing through the center O. Yes, we can tell that this is a diameter, right? And the diameter divides the whole circle into two equal parts. Yes, so that means our upper part over here is a semicircle and our bottom part is a semicircle as well. Now that we have that information, what then will be our first step? Our first step will be finding this angle right here, angle RSQ. Yeah, so that will be our first step. So let's find, first step, let's find angle RSQ, right? And how then do we find angle RSQ? We're going to use a second theorem, yes, which states that the angle in a semicircle subtended at the circumference is equal to 90 degrees. Yeah, so then what does that tell us about angle RSQ? That tells us that angle RSQ is equal to 90 degrees, right? Okay, so I'll just label it right there, 90 degrees, right? So then how do we come up with that? Yes, so let's try to understand how that second theorem works by taking you back to another second theorem, yes, which states that the angle at the center subtended by an arc is twice the angle at the circumference subtended by the same arc. What do we mean by that? Okay, so let's say we have, I'll just illustrate it here. Yes, we have this circle over here, yes, and let's get this, sorry, let me get just an angle at the center there. Yes, yeah, so this is my angle at the center O, right? Allow me to label this part as B and this part as my A, right? And then on using this same arc, we'll have another, yes, another angle at the circumference. Sorry, we'll have another angle at the circumference right there. Yes, this angle here, allow me to label that as angle C, right? So we have this arc over here, AB, and let's give the angle at the center as angle 90. Yes, now according to the second theorem, the angle at the center subtended by an arc, yes, is twice the angle at the circumference subtended by the same arc. So for us to find angle C over here, yes, all what we have to do is we have to what? To divide 90 by 2, and that gives us 45 degrees. So then we would say that this angle over here is 45 degrees. So then how does this information, yes, how does that information help us in knowing how this 90 degrees came up? Yeah, okay, so now we do know that angles on a straight line add up to what? 180, right? Okay, and it's at the center over here, right? And for us to get our 90 degrees over there, what are we going to do? Yes, it's at the center using the other theorem that I just talked about. So all we have to do is we have to divide 180 by 2. That will give us what? 90 degrees. So that's how that 90 degrees came up, right? Okay, so now I hope this information helps you understand, yes, on how the angle in a semicircle, yes, semicircle comes about, yes. Okay, so now let's move on, yeah. Yes, let's move on. Okay, so now that we have found our angle RSQ, yes, now our second step, yes, will now be finding angle SQR. And how do we do that? Yes, if we look at this shape over here, yes, you can see that this is a triangle, right? And we do know that angles in a triangle add up to what? 180 degrees. So for us to find angle SQR, all we have to do is we have to just add angle SQR plus, yes, angle QRS, yes, plus angle, yes, plus angle RSQ, and equating it to 180 degrees. Yes, now we know our angle RSQ is 90 degrees. Yes, plus we do know that our angle QRS, which was given, is 62 degrees. Yes, plus our angle SQR is what we are looking for, so we shall just write it like that. Yes, and we're equating it to 180 degrees. Yes, so we can simplify these two, we can add them. Yes, 62, yeah, 62 plus 90. What does that give us? That gives us what? That gives us 152. Yes, plus angle SQR equal to 180 degrees. Yes, so what then do? We just solve this equation. Yes, we minus 152 and minus 152 on the other side as well. So those two cancel out and we'll be left with angle SQR equal to, yes, 180 minus 152. What does that give us? That gives us what? 28 degrees. Yes, so we have now found our angle SQR, which is 28 degrees. Yes. Okay, so now let's take a look at our second question over here, and the question reads, find angle ABD. Yes, find angle ABD, which I have already labeled here. Yeah, okay, so let's get into it. Let's write our solution right there. Yes, okay, so now the first thing that we have to do, yes, the first thing that we have to do is we have to find angle DCA. Yes, we have to find angle DCA. Yeah, okay, so the first thing that we're doing is finding what? Angle DCA. Yes, now how do we find angle DCA? If we look at this line segment over here, DE, it's a what? It's a straight line, and we do know that angles on the straight line add up to what? 180. So for us to find angle DCA, what do we have to do? We have to add angle DCA plus, yes, angle ACE. Yes, angle ACE, and equate it to what? To 180 degrees. Yeah, and we already know that our angle ACE is what? 150, because it's been given. Yes, and we just drop down the angle angle DCA equated to 180 degrees. Yes, Okay, so now we can what? We can work out this part over here. Yes, so we just have to subtract 150 degrees from our left side, and we do the same. We subtract 150 on the other side, and we'll be left with angle DCA equal to, right, positive 150 minus 150, those cancel out. Yes, so that's the reason why we was left with DCA, right? 180 minus 150, that leaves us with what? With 30 degrees. So now we have found that our angle, yes, DCA is what? Is 30 degrees, right? Okay, so now what are we going to do next? Let's talk about our second step. Yes, our second step would now be finding angle ABD. And how are we going to do that? We'll do that by using a circle theorem. Yes, a circle theorem that states that angles, yes, angles subtended by the same arc are equal. Yes, angles subtended by the same arc are equal. What does that mean? I'll try to illustrate it here. Yes, so let me draw a circle. Let's say we have this circle right here, right? Okay, so we have that over there. Yes, okay, and allow me to label this part as A, this part as B, C, and D, right? Now, remember I said angles, yes, angles subtended by the same arc are equal, right? So let's look at this arc over here. DC, yes? So which angles are subtended by this arc? Yes? So you find that it's this angle and this angle. So if this angle is 35 degrees, so if this angle is 35 degrees, that means this angle will be also be what? Be 35 degrees, right? And then if we look at, yes, if we look at this other arc over here, AB, yes, which is, yes, is obtained by what? This angle is obtained by arc what? AB, right? And this angle as well here is obtained by what? By arc AB. So if this angle D was 28 degrees, that means angle C will also be what? 28 degrees, right? Now, using our illustration over here, yes, using our illustration over here, what then does that tell us? Yes, what then does that tell us about angle ABD? Yeah, so that tells us that angle, yes, angle, sorry, that tells us that angle, yes, angle DCA is equal to angle ABD, using the circle theorem that angles subtended by the same arc are what? Are equal. Yes, and if we look at angle C over here and angle B, they're subtended by what? By this arc over here, DA, right? So that means if angle DCA is 30, that means our angle ABD will also be what? Will also be 30. Therefore, angle ABD is equal to 30 degrees. Yeah? Okay, so there we go. We have solved our what? Our second question. Yeah? Let's look at our other question.